Welcome to Spring Lib.
Okay, we have 3 molecules here. Each is a di-substituted cyclohexane. The first with a wedged chlorine on carbon 1 and a dashed chlorine on carbon 2. The second with a wedged chlorine on carbon 1 and, a wedged chlorine on carbon 1 and a wedged chlorine on carbon 2. And just so you know, I draw C script L. I do that so we can always distinguish between L's and I's if necessary, so it's pretty common in chemistry to draw cursive L's. Okay, and then the third molecule, again, cyclohexane, di-substituted, a wedge to chlorine on carbon 1, and a dash to chlorine, but this time now on carbon 3. And the question is, which of these is achiral? Right? And the answer is number 2. Now you may wonder what the reason for that is, and that's that molecule number 2 contains an internal plane of symmetry, specifically right across that line. That is, didn't draw it super straight. Let me again there. The left-hand side of this molecule is the mirror image of the right-hand side of this molecule. Okay, and if you have stereocenters but also containing a mirror plane of symmetry, then in fact the stereocenters don't result in the molecule being overall chiral, right? So this is a type of molecule that's known as meso as well, right? Or meso more specifically. You have 2 or more stereocenters, but the molecule contains an internal plane of symmetry. It is meso and achiral. Okay. Now you'll notice, like, if I try to do the same thing with this one, the left is not the same as the right because I have a wedge on the left but a dash on the right? And you could maybe try to do the same thing here. The line would be at a different place, but again, it might split the cyclohexane in 2, but suddenly, again, we run into wedge on the left and dash on the right.